the principle of moments. In the diagram we have, the system is brought to equilibrium position by forces F1 and F2. In the presence of F2 only, the system would move into a clockwise direction. So force F2 moves the system in a clockwise direction. On the other hand, force F1 would cause the system to move in anti-clockwise direction. We also note that the moment as a result of F2 which makes the system move in a clockwise direction is known as clockwise moment. That clockwise moment is calculated by taking F2 and multiplying by D2. Again, the moment as a result of F1, which is called anti-clockwise moment, is given as F1 multiplied by D1. When the system is in equilibrium position, F1 D1 is equals to F2 D2. And that is the principle of moments. The principle of moments therefore states that for a system in equilibrium, the sum of clockwise moments about a point must be equal to the sum of anticlockwise moments about the same point. Example, calculate the distance d in the diagram. From the diagram, We have a system brought to an equilibrium position by a number of forces. We have a force of 600 newtons, a force of 200 newtons, a force of 300 newtons, and that of 500 newtons. 600 newtons causes clockwise moment. Again, 200 newtons causes a clockwise moment. However, 300 and 500 newtons would make the system to move in anti-clockwise direction and therefore having anti-clockwise moments. So, by the principle of moments, sum of clockwise moments is equals to the sum of anti-clockwise moments. This implies that 200 multiplied by d added to 600 multiplied by 2 should be equal to 300 multiplied by 1.5 added to 500 multiplied by 2. Remember, we take the forces and their corresponding perpendicular distances from the fixed position we call the pivot. So this, as a result, gives us values 200d plus 1200 equal to 450 plus 1000. Collecting the like terms and simplifying, d is equals to 1450 minus 1200, which is divided by 200. This, when calculated, gives us a constant value which is equals to 1.25 meters. So the distance d for the system to be in equilibrium is equal to 1.25 meters.